Hey everybody, just want to welcome you to week 11, module 11 for ME 270 structural dynamics. So this week we're going to take a look at chapter 10. In chapter 10, what we're going to focus on here is vibration properties of multiple degree of freedom systems, looking at modes, frequencies, and damping. So a couple bookkeeping items for this week here. We have that quiz number 11 is been posted to Blackboard, and that'll be due on Friday the 9th by 4 p.m. And the other big ticket item here is we have your exam number 2 for the semester. So this will be released on Wednesday the 11th at 6 a.m. and you'll have 12 hours to complete it. It'll be due that evening at 6 p.m. on the 11th as well. This is going to be the same format as exam number 1 and your homework assignments you guys have done before. So please reference back to the homework guidelines for details on your formatting, grading, and submission. And just a reminder, this week, as every week, I have office hours on Tuesdays and Wednesday mornings from 9:30 a.m. till 10:30 a.m. But if these times don't work for you, just send me a message, an email, a chat through Teams, and we can set up a time that works well for both of us. So some details on exam number 2. So exam number 2 is going to be the same as exam number 1 as far as the fact that there's going to be 2 problems. Again, it's going to be assigned on the 11th at 6 a.m. It'll be due on the same day by 6 p.m. Problem is going to be very similar to the same things you've seen in your homework and in the in-class examples. It's going to be take-home format, but please work alone. Don't Google search answer solution manuals or Chegg or anything like that. It'll be very apparent if you've copied the solutions there. It's going to be open book, open notes, but please work alone. Make sure when you do your work, show everything in the correct units. Write out all the givens, finds, diagrams, the same as your homework format from before. The easier it is for me to read through your solution, the easier is it for me to award you partial credit on any of your answers. Grading criteria is the same as before. 2 points for format, 2 points for neatness, 2 points for having the correct method or approach, and 2 points for your final correct answer. So again, even if you get your answer wrong, you still have 8 points if you set your format up right and had the right approach to it. Hints. So this could be anything from chapter 6 up through chapter 10 here, but it's going to be one of the problems will be a spring mass damper problem involving your FFT, and the other will be a 3 degree of freedom spring mass system where you're asked to determine your mode shape. So that's what areas you can focus your studying on between now and next Wednesday. So as we jump into chapter 10 here, a lot of different things will be covered within this chapter. We're focusing again on modes, frequencies, and damping. So go through a couple of the different key terms that we're going to utilize within this chapter for all those topics. Looking at mode shapes for undamped multi-degree of freedom systems. Talk about rigid bodies for undamped systems and conditions that leads to those. Orthogonality is going to be a big thing that we're going to discuss here. Fundamental frequencies of an undamped multiple degree of freedom system here. Talking about different methods, Rayleigh method in particular. Ritz method we're going to be taking a look at as well. Look at physical damping for matrix. So a lot of matrix math is going to be involved in this chapter. Equations of motion for viscous damped degree of freedom systems for some n degree of freedom. Simple state eigenvalue problems and looking at some eigenvectors, and then orthogonality again for equations for our state eigenvectors. Break this down into 2 to 3 sections. We're going to call it 11.1 and 11.2, but 11.1 will have 2 sections within it here. We're dealing with module 11.1. We're talking about our natural frequencies, some modes of undamped multi-degree of freedom systems, and some uncoupled damping of multiple degree of freedom systems. And as we get into the lectures for these, we'll specifically break this down a little bit more. Second section we're going to get into here for 11.2, so we're going to continue on with some viscous damping for complex modes and talk about mode shapes of damped structures with rigid bodies.